Welcome to the chemistry of the atmosphere. This topic spans over 4.6 billion years, from Earth's fiery volcanic beginnings to the modern challenges of climate change and air pollution. It is a favorite for extended response questions, so precision with key terms like greenhouse effect and incomplete combustion is essential for top marks. In this interactive study, we will uncover how the atmosphere evolved and how human activities are disrupting it today. Let's begin with the early atmosphere. Let's map out the key stages. The early atmosphere came from volcanic outgassing, mostly carbon dioxide and water vapor, with some nitrogen and traces of methane and ammonia. There was no oxygen. As the Earth cooled, water vapor condensed to form oceans, and huge amounts of coal dissolved in them. This dissolved coal reacted to form carbonate rocks like limestone, locking away carbon. Later, photosynthesis by algae and plants released oxygen, gradually building the oxygen-rich atmosphere we have today. Turning to our core study notes, mastering these key terms is vital. The greenhouse effect is the natural process that keeps Earth warm. A carbon footprint measures total greenhouse gas emissions. Incomplete combustion occurs when there's insufficient oxygen, producing poisonous carbon monoxide and soot. Global dimming is caused by particulates reflecting sunlight. Peer review ensures scientific evidence about climate change is reliable. And sedimentary rocks like limestone tell the story of how coal was removed from the early atmosphere. Let's walk through how carbon dioxide was naturally removed. First, as oceans formed, coal dissolved and reacted to form carbonic acid, which then released carbonate ions. These ions combined with calcium to form calcium carbonate, which settled as sediment on the ocean floor, eventually compressing into limestone. Second, photosynthetic organisms like algae and plants consumed coal and released oxygen. Over time, some of this organic matter was buried and transformed into fossil fuels, locking away carbon for millions of years. Now let's work through a typical 6-mark question. To secure full marks, you must describe both natural evolution and human impacts. Start with the early atmosphere, high CO, no O. Then explain the two main removal processes, dissolution and photosynthesis. Next, note the increase in oxygen. Finally, discuss human activities, burning fossil fuels and deforestation, which release CO, enhancing the greenhouse effect and leading to global warming. Remember to use precise terminology throughout your answer. Watch out for common mistakes. Many students lose marks by confusing the greenhouse effect with global warming. The greenhouse effect is natural, while global warming is the result of an enhanced greenhouse effect. Also, be careful with combustion. Incomplete combustion produces carbon monoxide and soot, not carbon dioxide. When referencing climate data, always mention peer review to show how scientific knowledge is validated. And remember timescales. Natural changes take millions of years, but human-induced changes happen in decades. These details will impress examiners. To wrap up, the Earth's atmosphere has changed dramatically over 4.6 billion years. The early atmosphere was rich in coal from volcanoes, with no oxygen. Coal was removed by dissolving into oceans and by photosynthesis, which also produced oxygen. Today, human activities are reversing this trend by releasing large amounts of coal and other greenhouse gases, leading to an enhanced greenhouse effect and climate change. Remember the key terms and processes we have covered, they will be essential for your exam. Keep studying, and good luck!